So to finish this section then, let's do a couple more problems in terms of simplifying, and then I will once again recap a little bit. Let's take another example. Suppose that we have the fourth root of x times the third root of x squared. I mentioned to you earlier that if we have, if we're working with rational exponents, we don't want as rational exponents. The fourth root of x is the same thing as x to the 1/4 power, and the third root of x squared is the same thing as x squared to the 1/3 power. Okay. Then we can do something with these. First, second factor right here as x to the 2/3 power. We multiply the powers, remember? But now we're multiplying numbers with the same base. And we can go ahead and write this as a common denominator in the power, common denominator of 12. If I multiply 1/4 by 3 over 3, I will have 3/12. And if I multiply 2/3 by 4 over 4, I'm going to have 8/12. And so that's the same thing as x to the 11/12. So here we have a nice compact answer for this problem with radicals. And come up with a simplification that will help us. Okay. Let's look at one other example here. Suppose that we have the cubic root of x. Well, let's convert to rational exponents. This is nothing but x to the 9th to the 1/3 power. Here I have a base to a power. I can multiply the powers. And so this and that's the same thing as x cubed. So here we started with a radical, but we could have been working with a number x cubed, which is much easier to work with. So when you can, change the radicals to rational exponents to see if you have, if we end up with something that's a little bit simpler to work with. Okay. All right, to recap then, I would encourage you to do the following. When you are evaluating constants raised to rational exponents, for example, we saw earlier when we have 27 to the 2/3 power, we can say this is the cubic root of 27. The cubic root of 27 is 3, so we have 3 squared, and we end up with the number 9. Okay. Expressions. When we're simplifying expressions with radicals, with radical factors, let's say, change to rational exponents. To use the properties of exponents. And remember that rational exponents are, or radicals are nothing but rational exponents, and so we can make use of those properties of exponents, and that will help the simplification. Okay.